All right, our next unit of study, which we've already started with graphing, is beginning to learn how to graph linear equations. And a linear equation is a special kind of function. So the first thing that we need to know is what is a relation and what is a function. Now, any set of ordered pairs can be defined as a relation. If you have an x value and a y value, 3, 2, 7, 4, whatever two values, then that's a relation. But a function is a special kind of relation in which every element of the domain is paired with exactly one element of the range. If you look at the top of your notes, you'll see that is one of the first lines in there. So what exactly does that mean, though? Because that's a lot of math gibberish. So what that means is that if I have, say, a set of ordered pairs, say, for instance, I have 3, -2, and I have 4, 1, and I have -9, 0, and 3, 7, and -2, 1, and 5, -1. One thing that we need to be able to do is to determine whether or not this is a function. Now, again, definition of a function is every element of the domain is paired with one element of the range. So the first thing we need to know is what is the domain and what is the range. So the domain is just another name for our x values. The x values are also sometimes called your independent variable. Whereas the range is another name for our y values, also known as our dependent variables. The reason they're known this way is because most often when we have an equation, one thing depends on the other. For instance, you might say the amount of money you get paid depends on how many hours you work. So the number of hours you work would be your domain. That's what you choose. You choose how many hours you work. The range is what you get paid, which depends on how many hours you've worked. So that's our dependent variable. So when we refer to the domain and the range, what we need in order for it to be a function is for every value in the domain to have only one value in the range. That we also sometimes call this the input and the output. So every one input has only one output. So looking at this example that we have here, let's see if this one is in fact a function. So here I have the input 3 and I have the output -2. I also have the input 4 and the output 1. The input -9 and the output 0, 3 and 7, -2 and 1, 5 and -1. Now, the input 3 has an output of -2, but if you look, the input 3 also has an output of 7. So this would be a relation that is not a function because every input does not go to one output. We have one input, specifically the input 3, the domain 3, actually goes to two different values in our range. So this would be an example of something that is not a function. Now there's a couple easy ways that you can check if something's a function or not. Let's say that we have these values. If you'll look, this is example 1 on your notes. So we have -10, -34, (0), -22, 10, -9, and 23. So one way that we can do it is what's called a mapping diagram, in which we list in one little oval, we put our domain. In other words, we list all our x values. So we have -10, we have 0, we have +10, and we have 20. And then in another oval, we list our range or our y values. So I have -34, -22, -9, and 3. Then you draw a line going from the domain from the domain to the range. -10, that x value, and the input -10 gives us the output 34, -34. The input 0 gives us the output -22. 10 gives us the output -9, and 20 gives us the output of 3. So as we can see by our lines, each input goes to only one output. Now, let's say I were to throw another value in there. Let's say that -10 also goes to 4. Well, then we would have this. Now, we wouldn't draw -10 again because -10 is already in our domain, but -10 went to -34, but it would also go to 4. When we do a mapping diagram, if we see this, where one input has two different lines going from it, going to two separate output, then that tells us that it is not a function. If each input only has one line leading from it, then it would be an example of a function. Now, one thing to also keep in mind is, let's say that instead of adding that value, let's say that I add the value -5, -9. Now, if I add that value, now I have the original problem, but I'll need to extend this because I'm going to have one additional number in my domain, which is -5. I don't have to add another number in my range because -9 is already there. Now, this is still a function. There is no rule about how many different domains can lead to the same range. So as long as each number in the domain only has one line leading from it, as long as it's only going to one item in the range, then it's okay, and then it's a function. So this would be an example of a function. Now, a second way that we can test whether or not something is a function is something called the vertical line test. Now, if you look on your notes, they have a graph that looks something like this. Where we have 1, 2, 3, 4, and 5, and 1, 2, 3, 4, and 5. And we have one value at 1, 1. We have another value, and again, this is on your notes. We have another value at 2, 4. We have a value at 3, 2. Also one at 3, 5. One at 4, 3. And finally one at 5, 4. All right. The vertical line test says if you create a vertical line, which means straight up and down, then it cannot go through more than one point at the on the graph at a time. If you look, I could create a line going through this point, and as you can see, it only goes through just that one single point. Now, if I were to draw another line through my next point, you can see once again only goes through a single line. But if I draw a line going through this third point, notice this one actually goes through two different points on the line. So there are 2 points on that same line, which means this one fails the vertical line test, meaning this is not a function. Now, if you thought of that as an ordered pair, we would have the ordered pair 3, 2, and the ordered pair 3, 5. And here you can see the same thing. One input going to 2 different outputs. So this is why the vertical line test tests whether something's a function, because if you have a shared x value with different y values, or in other words, a shared domain with different values for the range, then what you're going to have is 2 points that lie on the same vertical line. So the vertical line test is another easy way to test whether or not something is a function. So let's look at the exercises in that page. If you look at exercise 1, since this is a set of ordered pairs, my suggestion would be only use the vertical line test if you are given a graph. So since this is just a list of ordered pairs, I would think the easiest way to do it, or the quickest way to show, is simply to make a mapping diagram. So let's do our domain in one oval and our range in another. So in our domain, in the example 1, we have -5. We also have 3, 1, and then we have 3 again, but we don't need to list it twice. It's already in the domain, so it's already listed. Now if we look at our range, we have 2, -3, 7, and 0. And if we were to make our mapping diagram, -5 is paired with 2, 3 is paired with -3, 1 is paired with 7, and 3 is also paired with 0. So here again we see one single domain going to 2 different range, which tells us this is not a function. Now, number 2, 3, and 4 are also fairly similar. 2 would be another good one to use the mapping diagram for, but I will let you guys do that one on your own. 3 is a good one to use a vertical line test because it's already drawn as a graph, so you could even take a ruler or a piece of paper and just slide it along and make sure that your vertical line only goes through one point at a time. And then number 4 is a set of ordered pairs, so again, a mapping diagram is probably a good choice to use there so that you don't have to create a graph. Now, on the back of the note sheets, we have another skill, which is function notation. Now, function notation is not a hard thing, but it can be a little bit confusing if you're not used to it. So I just want to make sure and get you used to using function notation. So remember we talked about our domain is x and our range is y. Well, another way we could write it is our domain is x and our range is what we call f of x. What that means is your range is a function, or in other words, is a dependent variable. It depends on what x is. So if x is 3, then f of 3 is your y value when x is 3. So the other thing that we need to do is just to be able to plug in values of x and solve for what y is for that specific value. So let's look at the example on your notes on the back. So if I have the equation y equals 5x minus 2, if I were to write that in function notation, I would write, instead of y, I would write f of x equals 5x minus 2. And then I could ask you a question, like, what is f of 4? And all that's asking is, what is your y value, f of x, if x is replaced with 4? So if f of x is 5x minus 2, then f of 4 is 5 times 4 minus 2, which gives me 20 minus 2, which is 18. So f of 4 would be 18. And again, all that means is that if I have the x value 4, the y value that corresponds with it would be 18. The advantage to function notation is that it tells us our x and our y value at the same time. It tells us the x value is this, the y value is this. So essentially it's giving us an ordered pair. So if you look at example 1 in your notes, we have f of x equals 3x plus 4, and the instructions say find the value for f of negative 2. So all we're going to do is take this equation and replace x with negative 2. So I have 3 times x, or 3 times negative 2 plus 4. And in order of operations, I get negative 6 plus 4, and that gives me negative 2. So f of negative 2 in this case equals negative 2. The last thing that we need to do is write an equation in function notation and then turn around and solve it. So if you look at example 2 on the back of your note sheet, it talks about Janie drove 210 miles at 42 miles per hour. Now, one thing you should always recognize in a word problem is that if you have something per hour or per day or per minute, anything like that, then that you should indicate to you that you are multiplying. So here we know that 42 times the number of hours is going to equal the number of miles. So our miles are going to be written as a function of the number of hours. Now, since it tells us that Janie actually drove 210 miles, then that we can replace m of h, because that's our dependent variable. The number of miles she drove was 210, and that's how many miles based on h number of hours. So then we can solve for h to figure out how many hours. So we get 210 divided by 42 is 5. So 5 equals h. So that tells us that Janie drove for 5 hours. So I would like for you to complete the exercises on the bottom. Just do numbers 1 through 4. And then numbers 13 through 17 on the back, along with the examples from the front that we didn't get to. And that will be all of your assignment for tonight, and we'll check those in class tomorrow.